Hello, Krishna.
Hello, sir. Good evening.
Good evening, Krishna. I'm audible properly, right?
Yes, sir, you're audible.
All right. And Alia, who sent you the link? Is this your batch? Nabil. All right. All right, Krishna. Any doubt from the last classes?
No, sir. Sir, I have a doubt from the assignments.
Assignments. All right. Tell me.
Sir, there was one question, sir. I think the question was from the textbook itself, which you have included in the assignment, right?
Wait a minute. Let me just get the assignment. You are talking about relation and function, right? Relations.
No, sir. The assignment 2. It was the heading assignment 2.
Wait a minute. Let me ask. You are asking about last week's assignment, right?
Yes, sir. So it was headed like assignment 2 relations and functions. Yes, sir.
All right, tell me the question. Which question you want?
1 second. So yes, sir. 5th bit, second one. I mean B.
Can you read the question, Krishna?
So R is equal to x comma y, where x is wife of y.
Yes.
We have to determine whether each of the following relations are reflexive, symmetric, and transitive.
Reflexive, symmetric, or transitive. I don't think. I think you got the wrong assignment. Give me a second. Krishna, wait a minute. All right, let me talk to the team. All right, just give me a second. It was headed assignment 2, right?
So assignment 2, relations and functions.
All right, give me a second. All right. Can you tell me the date which you got that?
Yes, sir. It's dated 6/5/2022.
6/5/2022. All right. That means
5th, sir. 5th yesterday. I submitted yesterday, sir. Yeah, because I have submitted yesterday, so it's dated.
All right, but you didn't get it yesterday, right?
Yes, sir.
Can you tell me when did you get it? When did this send? My team send this to you? When you received? Can you tell me?
Yes, sir. I think it is on Saturday. I think I received it Saturday or something.
Saturday. All right. All right. Give me a second. All right.
So, but I think it's an NCERT question. It's there in the textbook.
All right. No, it's not about the question being what. I'm not getting the assignment actually. Right. Give me a second. Team is forwarding that to me.
Okay, sir.
Yeah. Give me a second. That is okay. All right. And Shekhani, everything good?
Yes, sir.
Any doubts?
No, sir.
No doubts. Why didn't you submit the assignment?
Sir, I do not have the my account doesn't work on it.
You can forward that on WhatsApp also, right? From the WhatsApp number you get the links. You can forward the assignment to that number.
Sir, I do not get my assignments through WhatsApp.
How do you get? Is there any number of our team where you get WhatsApp updates or anything like that?
Yes, but they do not give assignments.
That is okay. You can send that forward your assignment to that number. All right.
No, sir, they do not give me assignments. From where do I get the assignments?
Then how do you get the assignments?
I do not get the assignments.
You don't even get the assignments at all.
Yes, sir. That's what I'm saying.
How is this possible? All right. Let me talk to the team. All right. Don't worry. Kulsum, what about you? Everything good?
Yes, sir, but I haven't submitted the assignments. I had
Why
a
not?
big doubt.
You have a doubt. All right.
And
Good.
sir, we have a unit test coming up this month, and we have the lessons. We might have inverse trigonometry or continuity and differentiation, that lesson. And for sure, we have matrices and determinants.
All right. And not this chapter, relations and
No,
functions?
not relations. We might have inverse trigonometry or continuity and differentiation. And the exam is on 28th.
28th,
No, 26th June.
26th. All right. Don't worry. Till then, by then, we'll complete inverse trigonometric. All right. And not continuity, but a little bit of continuity also. All right.
Okay, sir. I know
Yeah.
continuity is very long, so they might only give half of the chapters.
Right. Yeah, that is why also I'm also saying that we will not be able to complete that, but inverse will be completed. Don't worry. All
Okay,
right.
sir. Thank you.
And all right, Krishna, I got the assignment. One question, fifth part.
Yes,
Is
sir.
that the doubt? Relation
Yes, sir.
R in the set A of human beings in a town at a particular time given by this.
Yes, sir. That one, second last.
That one second last. That means part D.
Sir, D, sir.
D.
Yeah.
So 1, V, and D. This is what we are solving. The question says, tell if the relation is symmetric, reflexive, or not. What? So x comma y such that x is wife of y. So this is very easy question. Shekhani, can you tell me if this is reflexive or not? This is written as x is wife of y. All right.
Sir, it's not reflexive. It's impossible.
Why not? Right. Absolutely right. This is impossible. Wholesome. This is clear.
Can
Why
you
this is not
explain
reflexive?
again, sir?
All right. Shekhani will explain, not me. Shekhani, go on.
Sir, if x is wife of y, there should be three, right? X, y, and z, because we are talking about
We're talking about reflexive first.
reflexive. Yes.
So what is reflexive relation?
A B B C A C.
No. Reflexive, you should reflect on yourself, right?
Oh yes, A B. A and B like that, right?
Absolute right. So x comma x should belongs to R for that to be
Yes.
reflexive.
Yes.
Krishna, this is right.
Yes, sir. Sir, I'm having doubt for transitive.
All right. We will discuss all the points. All right. Don't worry. So, Kulsum, now is it clear? Can x be wife of himself or
No.
herself? No. So this is not reflexive.
Okay.
Now let's
Yes.
talk about symmetric. Kulsum, what will be the answer here? If x is the wife of y, then can y be wife of x?
Yes.
How?
No. If X is the wife of Y, then Y cannot be the wife.
Right.
X
So
will
this
be
is
the wife.
this is also not symmetric, right? If x comma y belongs to R, then y comma x cannot belong to R. Now this is transitive. All right. Let's talk about transitive. Now, Krishna, can you explain how this will be transitive or not?
Sir, we should let two ordered pairs x comma y and y comma z, and then x comma z should be possible, but it's not possible, right?
Absolutely right. This is not possible because if x is wife of y, and in fact y cannot be wife of z even, right? So this will be transitive, Krishna. Let's see how. See, you cannot have two pairs like this even, right, in the same set. This is right, because if x is wife of y, then y cannot be wife of any person, right, Krishna?
Yes, sir.
So you cannot have even this element here. And remember,
Yes.
if this has to be transitive, then you must have these two pairs to compare, right?
Yes, sir.
So this will be transitive, all right, because we can never have these two pairs, all right.
Okay, sir.
All right, then Kulsum, this is clear.
Yes, sir, it's clear.
All right, Shikani.
Yes, sir.
All right, and Ronaldo is also here. Ronaldo, everything good?
Yes, sir.
Have you submitted the assignment?
Sir, I have completed just a little left, sir. So I'll complete that and submit it.
All right, all right. All right, then let's move on with the class. No doubts, anyone from the previous classes, right? Anyone has any doubts from the last classes?
No, sir.
No. All right. Let's solve the question then. Kulsum, did you say you have any you had doubts from the assignment or not?
Actually, sir, I was out of town this last weekend, so I couldn't complete the assignments. I couldn't even attend the class.
All right, all right,
I'll see the assignment and then I'll ask.
all right, all right. Yes, in the last class you were not there. No, you were there in the last class, I think.
Not maths class, my other class.
All right, all right. Let's solve one question. Determine whether each of the following are reflexive, symmetric, and transitive, where the relation is given as relation R on the set A 1, 2, 3, 14, and R is given as x comma y such that 3x minus y is equals to 0. All right. Solve this one and tell me the answer in the chat if this is symmetric, sorry, reflexive, symmetric, and transitive. You guys can solve this, right?
Yes, sir.
Yes, sir.
All right.
All right. Shikhani, team is saying all the assignments are mentioned in your account.
Sir, in the WhatsApp, I did not get a single assignment.
All right, in the portal. Do you get the assignments? How do you all get the assignments?
It's on the
In
website.
the portal.
In the portal, right? So Shikhani, have you checked the portals?
Sir, let me try the portal.
All right,
I got the answer, sir.
you got the answer. Kulsum, what is the answer here?
When I put 1, 2, 3, and 4 as x, and I got the answer 1, 3, 2, 6, 3, 9, and 4, 12. After that, with 5, it's not coming. And for reflexive, it's not reflexive because 1,
Right.
1, 2, 2, 3, 3 is not there.
Absolute right. So this is not reflexive. And
It's not
Ronaldo,
symmetric.
Kulsum, let Ronaldo answer now about symmetric. All right. Ronaldo, how is this not symmetric, or if this is symmetric, how is that symmetric?
So it's not symmetric.
Why?
Sir, because with 1, 1, 2, 2, 3, 3, 4, 4, it's not it's not either reflexive or symmetric. And with 1, 2, it's with 1, 2, it's not symmetric, but, because 2 and also is not symmetric.
All right.
And with 1, 3, for 1, 3, it's symmetric, but for 3, 1, it's not symmetric.
Right. But Ronaldo, we don't say it like that, right? We say, see, we can write the elements belonging to R, right? Like Kulsum said, let's start with 1. If we put 1 here, then what will the value of y?
1, 3.
1, 3. Then what will be the next element?
2,
If I put
6.
2, 2, 6, and 3,
3, 9.
3, 9,
3,
4,
9.
12.
And then
4, 12.
4, 12. Any other element?
No, sir.
No. So we can say that all of these elements belong to R, right? Now you can check from here. Let's check reflexive. So clearly 1, 1 does not belong to R. So this is not reflexive. All right. Now symmetric. We can see that 1, 3 belongs to R, but 3, 1 does not belongs to R. So this is not symmetric. Now Ronaldo, you can see if even one element misses its counterpart, then the whole relation is not symmetric. All right, we don't say that for 1, 3 this is symmetric but not 3, 1. All right, because the both of them are necessary for the relation for to be symmetric. All right.
Yes, sir.
If one of them misses the counterpart, then the whole relation is not symmetric. All right, everyone is clear about this?
Yes, sir.
Yes, sir.
All right, Krishna, is it transitive?
Sir, it's neither, sir.
Right, absolutely right. So this is not even transitive because we can see 1, 3 is there and 3, 9 is there, but
1, 9
1,
is not
9, absolutely right. So this is not transitive. All right, everyone is clear about this?
Yes, sir.
All right, and this is the way to write also, right? More clearly and with a better handwriting, but this is the format to give the answer. Do you want to note it down or shall we move on? Everyone?
Noted, sir.
All right. Let's solve another question. Relation R on the set N of all natural numbers defined as R equals to x comma y such that y equals to x plus 5 and x is less than 4. All right, you guys have to tell if this is symmetric, reflexive, or transitive. All right, I'll give you a few minutes.
So that it's only transitive.
All right,
Sir, x is less than y or less than 4?
less than 4.
So sir, it will be only transitive. It's neither reflexive nor symmetric.
Absolutely right, Shivani. Shikani, have you checked the portal?
Yes sir, I checked. It does not come over there.
Assignments are not there.
Yes sir. In some red color text is there on the portal page.
All right, all right. No worries, I'll talk to the team. Let me see what this is about. All right, and please check the portals after the class. All right, after a day at least, so that you get to see the assignments.
Done, sir.
All right, Kulsum, is it reflexive,
No, it's not reflexive.
symmetric,
It's not symmetric either.
and transitive?
It is transitive.
It is transitive. All right. Everyone is clear about this?
Yes, sir.
All right. So let's write relation set R, which will be, let's put x equals to 1. So we will get y equals to
1,
6.
6.
So 1, right? And
2,
2, 7,
7. 3, 8.
and 3, 8. So these are all the elements in R. Now we can see for reflexive, not reflexive, right? You have to mention that 1, 1 is not there, and so on. So not reflexive.
Sir, only one example is enough, right?
Right. If we have to prove that something is not reflexive or symmetric, then one example is enough. But if we have to prove this is symmetric or this is reflexive, then you have to generalize.
Okay, sir.
So about symmetric, again 1, 6 is there, but 6, 1 is not there, so not symmetric. And transitive. Why is it transitive? Anyone can explain?
Because special case sir.
Special case.
There
Right?
is nothing
Because
to compare to.
nothing to compare to. How to write this? We can write in, we know 1, 6 belongs to R, but no ordered pair starts with 6. And this is the case with 2, 7 and 3, 8 also. Hence, this is transitive. All right, this is the way to write your answer. All right, everyone.
Yes, sir.
All right, then let's move on. Ronaldo, this is clear.
Yes, sir.
All right, next question. Relation R on set A equals to 1, 2, 3, 4, 5, 6. defined as R equals to x comma y such that y is divisible by x. All right, solve this one.
Sir, R is symmetric but not transitive and reflexive.
All right. Everyone done with the question?
Sir, it is y is divisible by x, right?
Right. Y is divisible by x.
Done, sir.
No,
All right,
wait,
let's-
sir. Actually, it is transitive.
It
It
is
is transitive.
reflexive, it is not symmetric, and it is transitive.
Sir,
All
it
right,
is
let's see.
symmetric because 1-1.
All right, let's see. Let's check reflexive first. All right. Let's write the relation first. What are the elements? So let's start with 1. 1 will divide 1. 1 will divide
1, 1,
2.
1, 2, 1, 3, 1, 4, 1, 5, 1, 6.
Absolutely right. Now 2 will divide 2.
2, 2, 3, 3, 4, 4, 5, 5, 6, 6.
Right. But I'm just talking about 2 will divide 2. Then 2 will divide
4.
4. Then 2 will divide 6. And 3 will divide 3. And 3 will divide 6. Right. 4 will divide 4
Sir,
only.
is it necessary to write the relation?
No, it's not necessary, but it's better, right? Because we can write the relation here, relation set, right? It's easy for us, and we
Yes.
can look at the elements and think about the answer very clearly, right? This is the reason to write, not necessary, but it's better to write wherever
Okay,
you
sir.
can. All right. Now let's reflexive. So this is reflexive because each element, each number divides itself. Hence, this is reflexive. About symmetric, 1, 2 belongs to R, but Shikani is 1 there. Shikani, does 2 divide 1?
No, sir.
No. So 1 comma 2 is there, but 2 comma 1 is not there.
Not there.
1 comma 3 is there, but 3 comma 1 is not there.
Not there.
So not symmetric. Like about transitive, let a comma b belong to R and b comma c belong to R. This means a divides b and b divides c. This implies a divides c. This is clear, everyone?
Yes, sir.
So a comma c belongs to R. That means R is transitive.
Sir, there is no number that is. It's
No
special
number.
case.
No, not special case.
How then?
See, 1 comma 2 is there and 2
Yes.
comma 2 is there, 2 comma 4 is there. So 1 comma 4 must be there. Right, Shikani?
Okay. Yes. Yes.
So there are many pairs like that. All right.
Sir, it's actually opposite, right? X is divisible by y means it's y by x, right?
Absolutely right. So did I write something wrong, Krishna?
No, sir. I mean x is divisible by y means I mean y is divisible by x, sir. It is.
Right. If I
So
write
it is
x comma
opposite.
y, yeah. If I write x comma y, that means y is divisible by x in the question. All right.
So sir, it is x by y, right?
No, no, no. Y by x. Y is divisible by x. Right, Krishna?
Okay, sir. Yes, yes.
All right. Everyone is clear, Ronaldo?
Yes, sir.
All right. So this is the way to write. Do you want to note it down, Shikani? Shikani, Kulsum, Krishna, noted it down?
Done, sir.
All right. Next question. Relation R on the set Z of all the integers defined as R equals to x comma y such that x minus y is an integer. Let's solve this and please write the answer properly. All right. Try writing the answers in the proper format.
R is equal to
R equals to x comma y such that x minus y is an integer. And x comma y is also integers because set of Z we are talking about.
Sir, I don't know how to solve this. Can you solve, please?
All right.
Sir, R is reflexive, symmetric, and transitive, right?
Absolutely right. Let's see how we can solve this. Kulsum, Ronaldo, have you solved this or are you solving?
Sir, I have solved for
Done, sir.
reflexive and symmetric, but I'm confused with transitive.
All right, let's see. Let's start with reflexive. All right, we can say that A comma A belongs to R because A minus A equals to 0, which is an integer.
Sir, I don't
This is clear?
understand anything.
All right, let me erase this. Let's rewrite this. See, Sekani, they are saying R is a relation of all the x comma y such that x minus y is an integer, right? And x comma y also belong to integer, right, Sekani?
Yes.
They are saying if you take any ordered pair of a comma b, then a minus b must be one integer for a comma b to belong to R,
Yes.
right?
Yes.
All right. So let's see. What does reflexive property say, Shekhani?
Reflexive property says A is to A.
A, right? So that means every element should be related to be itself. That means if we have to say a comma a belongs to R, that means a minus a must be an integer. Is this clear?
Yes.
So can we say that a minus a is equals to 0, right? If you cancel one number from itself, that means we'll always get 0, which is an integer, right? 0 an integer. Shikani, this is clear.
Yes, sir.
So can we say a comma a belongs to R or not?
Yes.
So so R is reflexive.
Yes, it is.
Now look at symmetric. In symmetric, we say that if let a comma b belongs to R, right? If a comma b is there, then b comma a must be there.
Yes.
So we say let a comma b belongs to R. This implies that a minus b is an integer. Let's call that lambda.
So it will be symmetric.
Absolutely right. So if a minus b is equals to an integer, this implies that b minus a is equals to minus lambda. This is also an integer, right?
Yes.
Because negative of an integer is also integer. That means b comma a also belongs to R. So this is transitive. Sorry, symmetric. Now let's talk about transitive. If a comma b belongs to R and b comma c belongs to R, then a comma c must belong to R for this to be transitive, right? Ronaldo?
Sir, it is transitive.
Yes, sir.
It is transitive, absolutely right. So how to prove that? This implies that a minus b is an integer. Let's call this p. All right. And b minus c is also an integer, q. All right. Where p and q are integers. If we add two integers, will we get another integer or not? Ronaldo?
Yes, sir.
So we can say, so adding a minus b and b minus c, we get, suppose r integer. So we can say that a minus b plus b minus c is equals to r. That means a minus c is also equals to r, which is an integer. So we can say that a comma c also belongs to r. So this is transitive. Is it clear, Ronaldo?
Yes, sir.
Everyone, this is clear?
Yes,
Sir, we
sir.
can claim it directly instead of adding, right? We can do that.
You can do that. Yes, you can claim that directly, that a minus c is also an integer. But this is better, right? Because you showed them how you got to the result, right, Krishna?
Yes, sir.
This is one simple step. Always try to do very clear in board examinations. All right, because see, the question is very easy. They might not give you marks if you skip steps. All right,
Okay, sir.
so that is why I'm solving all the questions, so that you get to know the pattern, how to write the answer. All right, if you look at my answers, all the patterns are similar, right? So
Yes.
please note it down and always answer these questions in this format only. All right, in complete detail. Also, this is clear.
Yes, that's clear.
All right. Noted it down, everyone.
Just a minute, sir.
All right.
So done.
All right. Another question. Check whether the relation R on R defined as R equals to A comma B such that A is less than equals to B is reflexive or transitive or symmetric. All right. This, there are two R's here. This R means relation R. On R means on real numbers. All right. Two R's
Yes, sir.
here. One is relation, other is real numbers. Don't be confused. All right. This you have to check if this is symmetric, reflexive, or transitive.
Sir, can you do this question?
So R is reflexive and transitive.
All right. What about rest of you? Ronaldo, Krishna?
Sir, how do you do this?
I'll solve this, Shikani, don't worry. Let others try to solve. All right. Krishna, are you solving this?
Yes, sir. So I think R is reflexive, symmetric, and transitive. All.
All right, all of those. All right. Ronaldo?
Sir, I think that R is reflexive and symmetric, but not transitive.
All right. So each of you have different answers. Let's see. So first one is reflexive. So we can say that A is always less than equals to A. Is it right or not?
Yes, sir.
Yes.
So A comma A always belongs to R. So R is reflexive. This is cool, everyone?
Yes.
All right. Let's see what is the thing about symmetric. Let A comma B belongs to R. So this implies A is less than equals to B. So now Krishna, can we say that B is also less than equals to A?
Yes, sir.
Yes, if 1 comma 3, let's suppose I take 1 comma 3. So can we say 3 comma 1 also belongs to R? Because 1 is less than equals to 3. This is true. So is 3 is also less than equals to 1? Is it a true statement?
Oh, no, sir. No, sir.
No, right? Shikani, this is clear?
Yes, sir.
So we just have to write one example here. So we can say 1 comma 3 belongs to R, but 3 comma 1 does not belong to R. So this is not symmetric.
So, but it is true for equal, right? Like if A is
Right,
equal to B.
absolutely right. But I told you for something to be not symmetric, you just have to find one example. One is enough. All right.
Sir, in that case, 1 comma 1 also we can say it's true, right?
No, 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 no. See, Krishna, if you write the relation set, 1 comma 1 is there, absolutely right. 2 comma 2 is there, absolutely right. But 1 comma 3 is also there, but 3 comma 1 is not there. All right. So we have to, for symmetricity, we have to check all the elements, right? I told you, even if you miss one element, then this is not symmetric. All right.
Okay, sir.
Even if the 99% is correct, 1% issue is still an issue. All right. So never think about that is symmetric, that is symmetric. This is one relation. All right. This is one single set. If one element misses something, then the whole set has to be named as not symmetric. Now let's see about transitive. Let A comma B belongs to R and B comma C belongs to R. This implies that A is less than equals to B and B is less than equals to C. So can we say A is also less than equals to C? Can we say this or not?
Yes, sir.
Shikani?
Yes, sir.
All right. So we can say that A comma C also belongs to R. So R is a transitive relation. This is clear, everyone?
Yes,
Yes,
sir.
sir.
All right. So note it down.
Done, sir.
All right, next question. Let S be the set of all points in a plane and R be a relation on S defined as R equals to P comma Q such that distance between P and Q is less than 2 units. Check if the relation is reflexive, symmetric, or transitive. All right, write the question down, everyone. All of you understood this question, what the question is saying? Krishna, Kulsum, Shikani, Ronaldo.
Yes, sir.
All right. Shikani, the question is clear?
No, sir. Can you say again?
All right. See, in the question, they are saying let S be a set of all the points on a plane. All right, you take one plane and let all the points on that plane be on the set S. All right. So this is a plane. Suppose all the points, collection of all these points, we call the set S. Now they are saying R be a relation such that of P or Q such that the distance between PQ, you take any 2 points and the distance should be less than 2. If the distance is less than 2, then P comma Q belongs to R. This is clear, Shekhani?
Yes, sir.
See, in the previous questions, we were saying A comma B such that A minus B is equal to 0, right? The same thing is happening here. But instead of numerical
It's
examples,
saying
we are
it's
trying
less
to
than
calculate.
2.
Right. They are saying the distance should be less than 2, not subtraction. Distance.
Yes.
Distance between 2 points. All right. So try to solve this, everyone. I'll give you a few minutes. First, try to think if this is symmetric, reflexive, or transitive. All right. When you get the answer, then try to think how to prove that. All right. Don't try to prove at once.
So it is reflexive and symmetric.
All right. Anyone else has the answer?
Sir, it's reflexive. It is symmetric, but it's not transitive.
Not transitive. All right. Krishna?
Yes, sir. Same, sir. Reflexive and symmetric, but not transitive.
All right. Ronaldo?
Yes, sir, the same. Reflexive and
Same.
symmetric, but not transitive.
Can anyone tell me how to prove this?
So we can take like this 0.11, and then we can take 0.12, and then 21, 22, 23, and 32.
Then you can prove that they are
Yeah, we can prove 1 is reflexive, and we can show it's why it's symmetric. It's like 1 2 is there and 2 1 is there. That's symmetric.
I told you, Shikhani, if we have to prove something is true, then we have to write the generalized form. Right? You cannot prove by examples. If you have to prove something is not true, then you can take examples. All right.
Okay, sir.
And the other thing is, one point has two coordinates, right? On a plane, that means 1, 1 is a single point P. For this to be reflexive, P, P should be on relation. That means we have to create an element as this. This will be the element. This will be one ordered pair. Everyone, this is clear or not? I think this is a bit
Yes, sir.
confusing.
Sir, we should not give example, right?
Right. I'm just telling, if you have to take any point, then you have to take one point as 1, 1, another point as 2, 3. Right? 1, 1 is not 2 points. This is a single point.
Yes.
All right. So how we can prove?
So we can let a point p comma p. Then this shows that p is p. The distance between p and which is itself is 0. So it
0.
is reflexive.
Absolutely. We can say from the start that the distance between any point P from itself is 0, which is less than 2. So P comma P will belongs to R. So R is a reflexive relation. This is clear, everyone? Everyone, this is clear. This is the way
Yes,
to
sir.
prove
Yes, sir.
this is to be reflexive. Shikhani?
Yes, sir. Understood.
All right. Now symmetric. We can say let P comma Q belongs to S. All right. There are let P comma Q belongs to S. 2 points P comma Q who belong to S. And P comma Q belongs to R. That means the distance between P and Q is less than 2. Right? If P comma Q belongs to R, that means distance must be less than 2. Now, Shikhani, if I say the distance between a point A and B is 2, then what will be the distance between B and A?
2.
2. Absolutely right. So if the distance between P and Q is less than 2, that means the distance between Q and P is also less than 2. So we can say Q comma P also belongs to R. This implies that R is a symmetric relation. This is clear, everyone?
Yes, sir.
All right. Now, transitive. Is it transitive or not?
No, sir.
No. All right. So can you tell me one example where this is not transitive? Anyone?
Yes,
Any example?
Yes, sir.
3.
It's easy.
So if we suppose 1 comma 2 and 2 comma 3, so the distance between 1 comma 3 is not the same as 1 comma 2 and 2 comma 3.
No, they are not saying the distance should be same. They are saying the distance should be less than 2. And the other thing, we have only assumed 2 points, right? Remember transitive, A comma B should belongs to R and B comma C should belongs to R. Then A comma C must be there. If you say this is P, this is Q, this is only one pair, right? P comma Q, we are talking about P comma Q. What about Q comma R or Q comma S?
Sir,
Sir,
if
Get
the
my
we
point,
should take an
distance
example.
between, sir, if the distance between P and Q is 2 and the distance between Q and R is 2, the distance between P and R will be 4. So it's not possible.
No, not always, not always. Let me give you an example where this is true. Suppose I write, give me a second, all right. Suppose this is a point and this is a point and this is another point, all right, A, B and C. And this is suppose 1.5 and this is suppose 1.3. All right, Shikani, if AB is 1.5 and BC is 1.3, will AC be more than 1.5?
No.
No. So how can you say this is not transitive?
So, sir, in such case, how will we know if it's possible or not?
Yes, that is what you have to think, right? There is no trick here. You have to think about, can you think of any example where you can prove that this is not transitive? Anyone? Ronaldo, any ideas? Kulsum? All of you answered correctly that this is not transitive. But why?
So we can do like this, right? Distance between 0 comma 0 and 1 comma 1 and distance between 1 comma 1 and sorry, I missed.
1 comma 1 and
So I'm telling the same thing again.
all right. And the distance between 0 comma 0 and 1 comma 1 is what? What is the distance between them?
No, sir.
These 2
Actually,
points?
no, sir. It's not transitive, right? I messed up. Sir.
All right. What happened to rest of you guys? You fell silent.
Sir, so it is transitive. R is transitive.
So this is transitive because we cannot find any examples there. So this will be transitive, right, Shikani?
Yes, sir.
No, we don't think like that. All right. See, this is very easy. If I draw a straight line, all right, Shikani, one point is A, another point is B, and the point is C. If this is 1.5, this is 1.5, will AC be less than 1.5? Shikani, what will
So
be the
it will be
distance of
more.
AC?
AC
Right,
is
this is
3, not
3,
3.
right? So AB is less than 2, BC is less than 2, but AC is not less than 2. So this is not transitive.
Sir, that's the
Because
example I gave at the beginning, sir.
no, you didn't say it is straight line. You said,
Okay.
sir, it will always be more than this. So I gave you this example. Right, Shikani?
Yes.
So how to take examples? Transitive. See, keep one point constant, right? In a straight line, we don't have to take 1 comma 1, 2 comma 3, something like that. You take any point, keep y constant or x constant. All right, let's keep y constant, change only x. So we can say 0 comma 0, 1 comma 0, and this is 1, this is 2 comma 0. All right, let this be 3 points belonging to S. And we can say let P, Q, and we will not say T. P, Q, T, P, 3 points belonging to S with coordinates 0, 0, 1, 0, and 2, 0. All right. So distance between P and Q is 1 units, right, everyone? Distance between P and Q is 1 units only.
Yes.
Yes, sir.
So P, Q belongs to R, and we can say distance between Q and T is equals to 1 units. So Q, T also belongs to R, but distance between P and T is 2 units, which is not less than 2. So P, T does not belongs to R. So this is not transitive. Is this clear, everyone?
Yes, sir.
Shikani?
Yes, sir.
All right. Kulsum, Ronaldo?
Sir, so it will be only in a straight line that it won't be transitive.
Not always. This is just an easy example to think. If you draw any point like this, one point is here, one point is here, and the point is here. Even then, this distance will be more than 2, right? This can be 1.5, this can be 1.5, but this
Yes.
should be, all right? So in straight line, we can prove that very easily by easy examples. All right, otherwise you have to calculate the distance by using that formula, right? Your favorite formula, x1 minus x2 square plus y2 minus y1 square under root. This is clear, everyone?
Yes, sir.
Yes, sir.
All right, note it down. This type of questions always come in the exams.
Sir, what is after let P, Q, T be 3 points that belong to C?
Belongs to S. Belongs to S.
Sorry, S,
Uh,
comma.
remember that this one. Yes, with coordinates. This is with coordinates. Actually, my video comes there, so I cannot write here. All right, this is with coordinates.
Done, sir.
All right, another question. Check whether the relation R on this set are of all the real numbers defined as r equals to a comma b such that a is less than equals to b square is reflexive, symmetric, or transitive. All right, this is the question you have. Think about this and tell me the answer. All right, and try to solve this in a proper way. The first step would be to think if this is reflexive, symmetric, or transitive. All right, and I'm making this questions a bit difficult. All right, the question says show that this relation is this, but why not make it a bit difficult? So you have to think if they are reflexive, symmetric, or transitive. All right, the question is clear, everyone.
Yes, sir.
All right.
So the relation is reflexive, symmetric, and transitive.
All right. So the relation is all three.
Sir, I
Kulsum,
got it as none. None of the
you got
three.
it as none. All right. Shikani,
Yes, sir.
what is your answer?
Sir, I don't understand this question, sir.
You don't understand this question. Ronaldo,
Sir, I have a doubt. Like, can we take the numbers in negative?
absolutely. The set is on
Real
R,
numbers.
right? So you can take any number.
Okay, so just give me a minute. I will solve and tell you.
All right, all right. Got the answer, Ronaldo?
Yes, sir.
What is the answer?
Sir, R is reflexive but not symmetric and also transitive.
All right, let's see. All right. If I write 1, 1, this is belongs to R, right? Because 1 is less than equals to 1 square. So this is absolutely right. But if I take any fractional number, that means 1 by 3. So is 1 by 3 related to itself? Can you guys check? Krishna?
No, sir.
No, right? Because 1 by 3 is not less than equals to 1 by 9. This is wrong. So this is not reflexive. Is it clear?
Yes, sir.
Yes, sir.
Right. So don't forget about fractional numbers. And symmetric. Symmetric is very easy, right? 1, 2 belongs to R, but 2, 1 does not belong to R. Right, Krishna?
Yes, sir.
So symmetric is very easy. Now transitive. How to check for transitive? Kulsum, can you tell me an example?
Sir, first I took 2 and 3. It was symmetric, but then I took 2 and 5. Then it's not symmetric.
No, I'm talking about transitive.
Okay, transitive. I took 1, 2, 3, and then it was transitive. Then I took with negative numbers, I took -1, -2, and 2.
Right. So -1, 1 and 1, 2. Are these your numbers, Kulsum?
Yes.
All right. So let's see. This belongs to R, right? So -1 is less than equals to 1 square. This is 2. And this also belongs to R. Absolutely right. But if I want to take this, no, this is transitive, Kulsum.
2,
-1.
-2, and -1, it's not transitive.
Tell me what ordered pairs you took.
2, -2, -2, and -1.
-1. All right. Right. This is not transitive. Absolutely right. So guys, if you take these examples, all right, let this belongs to R and this belongs to R. Now 2 is less than equals to 4 minus 2 square. This is true. And minus 2 is less than equals to 1. This is also true. But if you try to take 2 comma minus 1, here 2 is not less than equals to 1. Right? This is false. So 2 comma minus 1 does not belongs to R. Hence, this is not transitive. This is clear, Krishna?
Yes, sir.
Shikani?
Yes, sir.
All right. Ronaldo, this is clear?
Yes,
All right. So this is the example to take 2 comma minus 2 minus 2 comma minus 1. Let me erase everything else. All right, note it down.
Done, sir.
All right, another question. Let a equals to 1 comma 2 comma 3. Then show that the number of relations containing 1 2 and 2 comma 3 which are reflexive and transitive but not symmetric. is 3. All right, what the question is saying is you have to figure out a relation on A such that that relation must contain 1, 2 and 2, 3 and should be reflexive and transitive, but should not be symmetric. And you have to prove that those kind of relations are of 3 types, or 3 relations are possible of such type. The question is clear, everyone? Who is thinking this is a very difficult question?
So can you explain the question again?
All right. See, they are saying try to write relations on A such that relation must contain these 2 elements and should be reflexive and transitive but not symmetric. Now, I told you when I was explaining about relations, don't try to think relations in equations, just think about subset. All right, so any relation on A means you have to take the ordered pairs from A cross A. So let's try to write A cross A first. So A cross A will be 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2 and 3, 3. All right. Now I told you relation is nothing but subset of this set. So just think about this question like this. You have to take such ordered pairs such that you must take these 2 in this relation R1, and whatever you write here, all those elements should be reflexive and transitive but not symmetric. Is this clear?
Yes, sir.
Shikani, Kulsum, Ronaldo?
Yes.
Yes, sir.
All right, and there is one thing to tell you guys, that in the next class there is going to be a viva, all right, of determinant and matrices. So please be prepared for that. All right, everyone, this is clear?
Yes, sir.
All right, try to solve this one. Let me solve first relation. All right, how to write, let me explain first, then I think you will be able to solve. So they are saying that relation should be reflexive. That means 1, 1, 2, 2 and 3, 3 must be there. This is right, everyone?
Yes, sir.
All right, now they are saying this must contain 1, 2 and 2, 3 also. So you must write 1, 2 and 2, 3. Now they are saying that should be reflexive and transitive. So reflexive we have taken care of. Now transitive,
1, 3.
so 1, 3. So let's check, this is not transitive because 1, 2 is there. 1, why should we write 1, 3? Krishna?
So there is no transitive element for 1, 2 and 2, 3.
Right. So we should write 1, 3 here for this to be transitive. So we can say this is transitive and reflexive, but is it symmetric, Shikani?
No, sir.
No, because we have 1, 2, but not 2, 1. So this relation R1 satisfies all the conditions, right? 1, 2 is there, 2, 3 is there, it is reflexive, it is transitive, but not symmetric. So this is one of relation or one of subset of A cross A. Now is this question clear, everyone? How
Yes,
to
sir.
solve?
Yes, sir.
All right, now we have to find 2 more relations of this type, R2 and R3. I'll give you a few minutes, try to solve this on your own. Take your time, there is no hurry, there is no rush.
Done, sir.
All right, everyone solve this?
Yes, sir, I'm doing the last one.
Doing the last one. All right, Kulsum,
I'm doing it, sir.
doing it. All right. Shikani,
Yes, sir.
solving it?
Yes, sir.
All right. Tell me when you are done, everyone. All right, have you solved this, everyone? Have you solved this or not?
Sir, I got only one with this.
Got only one. All right, let's see how we can solve this. So in R1 and R2, we have written these elements. So let's see what elements we can add to this. All right. In R2, we have to write these first five: 1, 1, 2, 2, 3, 3, 1, 2, and 2, 3, right? And we have to write 1, 3 for this to be transitive. Now let's see what elements can we add to this. So what elements remain This we have written, this we have written.
2,
This
1 and 3,
2,1.
okay, 2, 1 and
3,
3, 2 and 3, 1 also, right? These three we have not written. So can we add 2, 1 here? Does change any of this thing we need to write in this set? Let's see. This is still not symmetric because 3, 1 is not there, right? And this is reflexive. This is reflexive, but not symmetric. Is it transitive? Can anyone say this is transitive or not?
It is done.
It is transitive. 2, 1, 2, 3, 2, 2. Right. This is transitive. This is clear, everyone?
Yes, sir.
So this can be another relation. Now let's look at R3. 1, 1, 2, 2, 3, 3, 1, 2, 2, 3, 1, 3. These are necessary. Now instead of 2, 1, can we write 3, 2? Does this satisfy all the relations, all the conditions? This is reflexive, not symmetric, obviously, because
Sir,
3, 1 is.
3,1 as well.
You have to write 3, 1 as well. Why?
No, sorry. Like, okay, it's fine
No.
like this.
All right. So is this transitive, everyone?
Yes, sir.
All right, let's see. Yes, this is transitive, I guess. 3, 3, 2. No, we have to add 3, 2. See, we have 3, 3 and we have 3, 2, but we have added 3, 2. So yes, this is transitive, no worries. 3, 3, no. See, this pair is there, 3, 3. No, this is transitive. All right, this is transitive, so we don't need to add anything. So this is another relation. All right.
Yes, sir.
So in transitive, be very careful, because if you missed one element, then it would be wrong. All right. Kulsum, this is clear?
Yes, sir.
Ronaldo, Shikani?
Yes, sir.
All right then. So this type of questions is also there, and this is all for today's class. Any doubts?
No, sir.
No, sir.
No, sir.
No. All right then. Take care, guys. All right,
Thank
and
you, sir.
complete the assignments. As Shikani, you have to complete the assignments now. All right.
Yes, sir.
All right then. हम